So, yeah, I used to work for particular software, the makers of N-Service Bus, but currently I'm a cloud architect at Unisys. My group is the application services group. And what we do is in the group, Unisys is a big company, it's got a lot of clients. So we help the clients to modernize their current application architecture. So basically see what their current business friction points are and try to strategize and assess their existing framework and see how we can migrate it to the cloud so they can make use of all the cost savings and more importantly, make sure they're taking the full advantage of what cloud offers. So that's my current role. And a little bit about myself. I used to work for I this company, and the domain of the company was in servicing mortgage banks and banks and other servicers. So when people defaulted on their home mortgage payment, there's a whole set of regulations on like sending notices. The notices need to be sent out a certain way. And so when I first joined that company, it was in the 2009, 2010 timeframe. We had a real estate meltdown, and for this company, it was in the right space of, mailing out these notices, and it was a bad time in the real estate industry. The software that was written, was like a 5-year-old .NET application at the time. It couldn't keep up because of all the load. So my first job as an architect was to try to take a look at the architecture and see where the bottlenecks are and how could we scale. In that sort of journey led me into domain-driven design principles and both event-driven architecture. In trying to solve that problem, I was trying to see, how to identify the pain points and how could we solve it in a way that the application is scalable. That's how I got into domain-driven design and event-driven architecture. So I want to share some of my experiences of learning in this talk. And again, feel free if you have questions, just unmute yourself and just ask me, and I'll try my best to answer. So if we look at this screen, and let's say we wanted to model this, right? What do we see here? This is a cell phone case, and we actually were looking at cases for me because I'm the iPhone killer. I at one point refused to have a case, and I would drop the phone, and my kids were like, "Mom, you need a cell phone case." And so we were shopping for cell phone case. So I picked this example. So let's say we want to model this. As we can see, there's a lot of things like name, description, images. There's some deals going on. If you get the Prime card, or if you get Prime, you get like $70 off if you get the reward card. So there's a lot of stuff that's going on here. There's a lot of information. So let's say we're trying to model this. We might we might have a model for this called product. And we might put like all of the attributes that we saw on the page, like name, description, and images, and so on. But what does a product actually means? And if it depends on who you ask. A product could mean something to somebody in sales differently than someone who works in inventory or shipping. So a product might be a thing for the salespeople. It's a thing that has like lots of images and something that's marketable, right? And for the inventory, it's something that you have, or it's available, or it's not available. And they're more worried about how do we make sure we have enough of this whatever product thing is in our shelves. So they're more concerned along those lines. Now, for the people in shipping, it's something that has a dimension and weight, and it needs to get from one place to the other. So the rules and the focus of what a product is going to be different depending on who you talk to. But in language, they might refer to this thing as product, but the rules, the underlying rules are different. So when we try to model, like, have one entity called product, and then we start to add all these rules, right? At some point, it starts to become unwieldy and complicated, and you might find that there may be a lot of contradictions in your model, and it might have some really weird runtime behavior. For example, like, let's say the sales team, right? If, let's say it's Apple and they're trying to market the MacBook Pro Air, they're talking about how light this thing is. So the model product has this thing called dimensions. So, and now the shipping team sees that model and goes, oh, okay, we already have dimensions defined in the model. So both teams are now trying to use the same field for completely different purposes. So let's say they do a software update, right? And then what happens is, like during runtime, at one point in time, the dimensions displayed might be one value, and then when you're trying to do something else, and it could be different. So you might start seeing weird runtime behavior. I so apologize for the dog. So what needs to happen is, so we have these, we might try to mitigate this, right? So instead of calling it dimensions, we might call it sales dimensions or display dimensions or shipping dimensions to just qualify it, to make it mean something. But the minute we start doing that, we're now introducing language that's entirely different in our code than what the domain expert talks about. So the domain people, like the people in sales and the people in shipping, referred to this as weight or dimensions. They didn't say it was display dimensions or shipping dimensions. So the minute we start adding these qualifiers in our code, we lose the actual the meaning of the word that they were describing it. So now we're starting to do these internal translations in our head. So when they bring in new requirements about dimensions, now you got to figure out, when they are saying dimensions, is it shipping dimensions or is it like display dimensions? So now there's like a translation, there's a step that you need to do. So having a unified model does not serve a good purpose, since these rules are different. So domain-driven design gives you this idea, or something called as a bounded context. So a bounded context, you can think of the bounded context as a safe space. Basically, this is a space where the language is consistent. You can have different models that belong to a particular business process or concern. And so you can have multiple bounded contexts. I'm so sorry. I knew this was gonna happen. Oh my God. My dog is just having a really wild time. Just a second. Can you please let her out? So sorry.
Don't worry about that. It's normal.
There, you can see her. Crazy dog.
Beautiful dog.
Thanks. This is her walk time, so she's like trying to, yeah. Sorry. So bounded context, you can think of it as a space where your models are free to evolve, they share the same language, they share the same consistency, the transactional consistency. So anything that needs to have transactional consistency would live in that same space. So you can think about this as a space where you have different models. Now, sales and shipping, so all these things could have a different context. So in the sales context, you could have a model called product. In the shipping context, you can also have a model called product. Oh man. So I'm sorry, give me a minute. So, so as I was saying, you can think of these three things as different contexts, and each of these contexts you can have a model called product. And in the product, in the model product, you can have dimensions or weight. And the model that's in shipping would be different from the model that's in sales, and that's completely okay. By doing this, what it gives us is the freedom to evolve. So the shipping team can start making changes to their model because the rules for shipping that's going to involve dimensions are going to be entirely different from the rules that the sales team has. So by separating these two contexts out, in these models living in these spaces, these teams can work, have a lot of freedom in how they evolve this particular model. And also, it gives you the clarity. You don't need to prefix your attributes with, like, shipping or sales, or have these extra words. Your models can actually use like the actual domain names, whatever the domain experts are calling it. We can call it the exact same thing in our code as well. So it gives a lot of clarity by separating them. So now the tricky part is, okay, originally we had this one model, and we said we could split it into different things. And so the tricky part is, like, how do you find the boundary? Like, what belongs to one context versus what belongs to a different context? And should these things even stay together? Teenager. So I use some heuristics to try to figure that out. So one thing is I apply the transactional consistency rule. So I ask myself, will there ever be a business rule that says, if the product description starts with a D, then you should deduct the stock availability to 0? Like, if you don't have a rule like that, you're not going to have a transactional consistency where you need, where you're dealing with both at the same time. So that's a very good indicator of these two things does not need to be in the same model, right? Does that make sense? So that's one of the heuristic. The other thing is, you could start to split the context according to the business teams, because these business teams are already, like, working on a certain specialized set of rules. So you could start there and then see where things go, how it evolves. And so based on conversations with the domain experts, you're going to have a lot of conversations with the domain experts. And based on that, based on the business rules, you might find out, like, what you had, as part of this one model or this context may not actually belong in that context. So based on that conversation, you do want to refactor that knowledge. As the business rules change, you have to refactor, you have to bring in that knowledge and make our models, like, reflect that reality of that business rule. So there's going to be a constant understanding, learning from the domain, and then trying to refactor that knowledge back into our models. So you could start with the departments as a starting point. You could also focus on the actual business process itself. So in this case, Amazon says you get $70 off instantly if you get the Visa card. So what is the business process involved? What are the things that go together in this business process? And so you could try to get like, what are the things that are playing together, and maybe they belong in the same context. So there's a lot of there's a few ways that you can try to see and discern, like, what belongs in a certain context, how your models should be, and so on. So so far, are we good? Like, is everyone clear on like what's the purpose of a bounded context? Why is it that we can have like one model to have to show the entire to show the entire, our domain is complex. It's impossible to have one model to depict all the complexities and all the rules. So so that's why we have to split them into multiple models. And by having multiple models, we said that these are free to evolve. Different teams can work on those. We keep the language of the domain consistent in our code. We use the same language, what the domain experts speak and in the code. So when they bring in new requirements, we can take a look at the code and go and map it and figure out where this new requirement needs to be, and so on. So our code is also rich with the domain language. And but the thing is, now that we have like multiple contexts, in order for a system to be cohesive, there needs to be some communication. We might need some data from one context in order to make a decision. So how do we go about with this communication? And we want to do it in a way that it's loosely coupled and in a good way that's scalable and so on. So that's where, for me, event-driven architecture comes in. The style of event-driven architecture is, we're saying that our applications, our systems, our components can communicate with each other by sending messages. Just like real world operates on events. There's no call stack way of how we do things. Like, I'm giving this talk and the dog is running and I'm interrupted. So there's like, as things happen, I'm reacting and taking compensating actions. That's how the real world works. So in software, typically we tend to write our modules in a very synchronous way, like, step A, and then once this occurs, then we call the next step, and so on. So event-driven architecture says like, hey, instead of that, your programs can be, or your components and services could do its own thing. And when it needs to communicate, it can send a message to the other party, and the other component can receive that message and react to it in whatever way it wants. So that's the premise of event-driven style of architecture. And by adopting that style, we can make our applications more loosely coupled. So I want to take so when you're using event-driven style of architecture, we pass messages in our software. So if we classify these messages, we can classify into several types, but these two types are very important. We can classify them as commands and events. So your domain event is something that signifies that something significant to the business has happened. So it could be that, like in my old case of like the mortgage domain, it's like, whenever like the person didn't pay the mortgage, they've defaulted. So we need to send them a certified letter. So certified letter was shipped would be a domain event, because that is some significant to the business. Because once you send a certified letter, there could be other rules that need to happen, like, you know, some regulatory requirements that need to be fulfilled for the state and so on. So that is a significant event. Now, commands, on the other hand, are point to point. So we say it's imperative in nature. So we say do something. So it's like you know, make payment or process payment, as an example of a command. So the difference is that, like, commands are sent to one process or one component, whereas events are broadcasted. When an event is broadcasted, there are multiple parties that are trying to act on the event. So you only publish an event after a fact. So after the fact. So if all your database operations and the business process that you have been successful, then you go ahead and then publish an event. Whereas commands can fail. I'm not just talking about like a technological failure, like through an exception, but a business failure. So for example, when I say process payment, let's say that that component that was actually trying to process that credit card payment failed because the person didn't have enough funds. So that thing failed. It didn't throw an exception. It went through, it completed the operation, but the person didn't have enough funds. So that's a failure. So commands, when you send a command, you have to assume that commands can fail. So we always need to think about like compensating actions of what to do from a business perspective when commands fail. So as architects and leads and developers, so it's our duty to ask our domain experts and say, hey, what should happen, you know, when this command fails? And so are there any compensating actions? So the business could say, hey, you know, if it fails, retry the next day. And then if it doesn't get settled, then you need to send an email asking them for a different form of payment. So those business rules kind of guide you to go ahead and program these compensating actions that you need to take when this sort of business failure occurs. So when you're trying to design your application where you're trying to have these components and contexts like pass messages, you can try to design it in such a way that it can either send commands or it can send events. One rule that I follow is between bounded contexts, like if one bounded context is trying to communicate with another bounded context, it does by publishing events, because you can think of bounded context as like truly autonomous things. So you just tell, like you're just publishing what happened, you know, of significance within your bounded context. Another bounded context can listen to it and then go take appropriate actions based on the rules it has. But you don't send commands to the other bounded context saying like, hey, go do something, because it can fail. But you can use this command concept of sending a message within the same bounded context where you've got like, you know, multiple services running. And as part of, let's say, this bounded context is all about payments, right? So you might have a module or a microservice to just process payments. So you might send a command to it saying process payment. And then if it fails, then you might send a command to another service that says like, send this email notification out. So you could send commands, messages as commands within the same bounded context. But when you're trying to communicate across bounded context, prefer using events for better and more loosely coupled, to be more loosely coupled. So let's take an example. Let's say that we have a business requirement. Say that, you know, in aircrafts, when you have these companies, American Airlines, United Airlines, and so on. So let's say that you have a booking and they change the aircraft type Boeing 787 to 777 something, right? Now, when an aircraft type is changed, it might affect your booking. For example, you might have booked a special seat, like you might have the exit row, and based on the capacity of the airline, they may not be able to offer you that anymore. So they need to kind of like rebook you or give you a new proposal. And then you might choose to accept it, or you might say, hey, no way, just give me my money back. Let's just take a look at that requirement. So how do we go about, this is an example like of my Norwegian Airlines, when they canceled my flight. They sent me a nice email saying like, oh, we're sorry, but we have to make changes, and you have the option to either take our new flight or ask for a refund. And so if you look at that business process, and in terms of events, so you could think about a business process, and it can get started by an event from a different bounded context. So let's say in this example, you've got a flight planning context that's in charge of like managing flights. They have the schedules for maintenance, and they know what flight is scheduled for what. So they can make changes, and they can publish this event, aircraft type is changed. But that event can really affect the booking context, right? Because when an aircraft type is changed, the booking needs to change accordingly. So these are two different contexts, but by publishing this event that is of significant importance, the other bounded context can react to it and do whatever is needful. Now, when is an interesting word. Back in the old days of C++ and object orientation code, you were looking for nouns as helpful things to identify classes, right? If it's a noun, it's got to be a class. So in the event-driven world, you look for the word when or whenever. If your domain expert comes to you and says, hey, when this happens, or whenever this thing happens, or so when they say that, there's usually a significant event that's tied to that sentence. So when an aircraft type is changed, from that sentence, we know that aircraft type is changed is significant, and that can affect other parties. So that becomes an event. That can also be a heuristic of like how you identify your events. Now, when this bounded context receives an event, it might need to do multiple things. So it might need to, in this case, in the example that I gave you, it might need to find a new proposal, send a notification, and either accept the cancellation or, publish. It could publish another event based on whether the person canceled, the passenger canceled the booking, or whether they've accepted the proposal. It might publish an event. So one event can actually, multiple messages can take part in that one business process. So this brings up like an interesting problem. So usually when multiple messages are taking part in a process, we need to have some sort of state. Like, how will we know when the message notify passenger is received, or let's say we send that out and the passenger cancels it? So we no longer we may not need to send, or we might not need to process the new booking. So we might need to act based on the state, and it becomes tricky. And that's where the Saga pattern comes in handy. So a Saga pattern in the domain-driven world, design world, it's also called as the process manager pattern. So you can, these names sort of go interchangeably, depends on who you ask. So some purists would say that it's a process manager. It's not a Saga pattern. But I learned this as Saga pattern because I started using N7's Buzz like, I don't know, 10 years ago. And in N7's Bus and mass transit, it was called Saga pattern, and it kind of stuck. And there's a lot of other people who call it a Saga pattern as well. So the thing is, you can think of this as an orchestrator. It orchestrates and it keeps some state. So all it's doing is like it receives a message and it checks its internal state, what it needs to do, and it's just a coordinator. It's based on the state, it's sending another message or publishing an event. So that's all it's doing. There is no complex logic of databases or business rules that's happening. All this pattern is supposed to do is handle the messages coming in and going out based on the state. So this pattern can be quite useful when trying to deal with business processes that need to perform several things. So Jason, you can like interrupt like if there are any questions, and because I'm not monitoring the chat, so if someone has a question, just feel free to interrupt me, because I'm just like I don't know, I'm just keeping on going at this point.
Okay.
Yeah. So how do we go about like finding out like how do we design this business process? How do we model this business process? And that's where event storming is a really great technique that comes in handy in trying to actually figure out what the business process is that we're trying to model. Modeling with post-its is a lot cheaper than actually writing code and finding out that that's not what you're trying to do. So I worked for this company several years ago. We were trying to implement this business process. We were trying to automate this process. So there was this woman, she would get emails from banks saying like, hey, this is the template that you need to send when a person defaults on the mortgage. So she would like take that template, put that in, and then she needs to get approval from like the appropriate bank person, say, hey, this is template look right, and they need to approve. And then she would send it out. So we wanted to automate this process because we felt like she's doing this for like a lot of the clients. It would be nice if we had a portal where the clients like, sign in and push that stuff in, we make changes, they approve it. We thought we would be making her life easy. So what we did, we had a large elaborate process. We even hired a UX person. He was in New York at the time. And so he did the UX, and there was only one developer who's working full-time on this. So he developed the whole thing. It took him a month, and a back and forth, like local QAing and so on. And then when we actually tried to give it to her, the person that's actually whose life we're supposed to make easy, she said, this is like, this won't work. I can't use it because it doesn't do X, it doesn't do Y. How do I do this? So the point of the story is like, no one actually thought about like, setting up a meeting and asking her, the actual user of the software, of how things should be. So collaboration is key, and talking to the right people is key. So how do we make sure like we're not wasting money writing or coding up the incorrect thing instead of focusing on our efforts on like what's the actual business value that we're trying to build? And so collaboration between domain experts and other stakeholders becomes very, very important. Event storming is a visual modeling technique that can be used in order to draw these questions and try to understand the behavior of the business process. Because once, it's a way where we're making all our assumptions like very clear to everyone in the room, and it's visualized, it's out there. So when you see what's on the board, it's on the white paper with the post-its, and so the person next to you has the same understanding of how this, you know, business process should work. So it's a great collaboration tool. And in these days and ages, so the way it's done is like we gather all the important stakeholders of the domain of what we're trying to build in the same room, and then we put a large roll of paper on the wall. See, what normally happens is like when you have a whiteboard, your modeling or visualization space is only defined by that dimensions of that whiteboard. So once we fill that out, like we usually stop modeling and then start talking amongst ourselves, and no one's like actually capturing the important assumptions that are being made. All those important details get lost. But by spreading out like our visual modeling area, we've got the whole area so we can model it. So in event storming, there's Alberto's book on LeanPub that talks in great detail, and Alberto runs it as a 2-day workshop. There's several, day workshops on event storming. But in a nutshell, the goal here is you are trying to find out like what the important things that are happening, identifying them as events, and writing those event names, and then trying to identify what commands are being sent, and and since commands can fail, like what compensating actions you need to take. And so you're trying to actually figure out all the domain rules and assumptions, validate your assumptions. So whatever is in the domain expert's head is what you're understanding too. And then you can take that modeling and then translate it into code. Do we have any questions so far?
Yeah, I was gonna say there's actually a couple in chat.
Okay.
The first one is, how many models are too much?
How many models are too much? I actually don't know. So I would say the number of models doesn't matter. It's like are the bounded contexts, like the models within the bounded context, do they make sense? If they make sense, then it's fine, because what you have within one bounded context shouldn't really matter like how many models the other bounded context has. So those are two different things. So as long as you find the need to keep them separate and it actually makes sense. So let's say you have like 2 or 3 or 4 different models, and then you look at this domain rule, and then you find out that like, hey, this one here and this one here needs to have the same transactional consistency. So you start looking at those things, and so you could refactor and say, okay, in this case, I did have too many models, and then you collapse it into one. So that's something that you kind of find out as your business behavior goes, and then looking at inspecting that model and seeing that is the model actually making sense for the business rule that you're trying to implement. Should it be an extra one, or should you combine them? You can make those decisions based on that. Does that clarify?
I think so.
Okay.
Yes.
Yeah.
There's also the couple more questions.
Sure.
Do you want to just keep going?
Yeah.
With the questions? Yeah. Okay. So I guess one after that was, is DDD related to BDD or TDD in software development?
Yeah, I think they're all I think they're all important, right? I think the biggest point for me, what domain-driven design gives me is it's a set of principles. It's a set of principles that say, put the business behavior first. And like event storming and stuff, it's actually, when Eric wrote the book 15 years ago, there was no event storming. Event storming is somewhat new, and it was a technique that was invented to see, hey, how could we bring what's important to the domain? How could we visualize this? How could we model this? So when people started thinking about creative ways of how we can think more, put the behavior first. And I think BDD and TDD, they're all equally important when you're starting to model it and write tests that test the behavior. And then, test-driven development, you have your unit tests and integration tests and acceptance tests. Together, the system that you write is going to be good, and it's going to be aligned, more importantly, with what you're trying to do from the business side of things. So the whole point, I think, our job is to make sure that the stuff that we write is aligned with the business. So when business comes to us and say, hey, I want you to, this new thing that we want to see, we think it's going to make money, but we're not sure. We want to try and see if this is going to work. How could we support like new features in a way that makes sense without breaking everything else? So if we write our software putting these behavior first, then it would be much more easy for us to extend and to help business to try and experiment with these new ideas, and we can enable our business grow. So I think they're all important, and I look at DDD as a set of disciplines that help you think about behavior. It's so easy for us to think like we are so, I don't know, personally, I learned like, data modeling first and normalizing databases. It was always about structure. And I like, even though object orientation taught about like classes needs to have behavior, like it's so easy to lose the behavior part of things, and it's easy to focus on the structure because that's something we can see. Behavior is like, it's a little tricky and it's very fuzzy. So we want to put the business behavior first, and I think DDD, BDD, and TDD, they all kind of go hand in hand. Does that help?
Nice.
Yeah.
Yeah, I think that was a pretty good answer.
Yeah. Do we have any questions on event storming so far?
So there's one, is event storming the only technique that identifies bounded context / service boundaries? So
there's like several visualization techniques. Event storming is one. There's also domain storytelling. I think I forgot the name. So after the meetup, I will send resources for those visualization as well. So domain storytelling is also another technique where you kind of like interview your domain expert to try and understand more about the domain, the business rule that you're trying to get at. Event storming, I personally like event storming because it forces me to think in terms of like the significant events that are happening. And by thinking in terms of events, I already can visualize like, if I had a software component that's processing something, then if it publishes this event, then how, so it kind of like translates for me, because I like event-driven architecture and I use messaging for loose coupling. So it kind of, it becomes easier to take what you've done as event storming and then to translate it to code, or when you're ready to, write code, your name of the events become very obvious. So you're going to model your schema based on the name that you found, through your event storming process. So for me personally, I like event storming, but yeah, there are other techniques for modeling. So now, like, because like in the traditional event storming, like you see in the picture, there's a bunch of people gathered around and they're working trying to figure out the events and so on. So right now, in the days of social separation, there is a virtual tool, I think it's called Miro. And so you could use that tool as this modeling surface to try to do event storming. I personally haven't done it, but I think there are blog articles and other articles that show you how you can use this online visualization tool to still do event storming in the social distancing world. And I'll try to dig that article up as well after the meetup and send those out to Jason.
Was that Neuro or Miro?
Is it Miro, I think, M-I-R-O, I think.
Okay.
There's Miro, M-I-R-O, and there's also Mural, which is supported by IBM.
Ah, okay. Okay, cool.
I find that both Miro and Mural are relatively feature equidistant.
Okay. Do you have a preference, having used both?
I have a preference for Mural, but I also come from the UX community, and Mural started as a UX tool. So we'll say this is more of a compassion and friendliness thing, but you can use both of them equally. They're great. I'm also a big fan of Lucidchart if you happen to have it across your enterprise.
Okay, very cool. Yeah, awesome. Thanks. So moving on. So this is how I've used event storming before. So first step, like I identify, like on that business process, we had those 3 lines of requirements, right? So we said when an aircraft type is changed, you know, you're gonna have to send a notification, person can accept the proposal or they can cancel and get the money back and so on. So in that business process, what we're trying to do is like, what are all the events that can happen through that business process? One, the first event, the trigger event or the start event is aircraft type was changed. And then, you know, the other event, the booking context is going to take that and go, okay, they're going to process new booking. And so they could publish after that process says like, hey, you know, I've changed the booking. So there's going to be an event for that. And if the passenger said like, I'm not interested in this, then, you know, you're going to cancel the booking. So the booking is going to publish booking was canceled or booking was confirmed. So as a first step, I try to identify like in that business process, what are the key events that are happening? And I try, so everybody has a preference. Like Alberto uses orange sticky for events. My rule of thumb is like use whatever post-its, you know, that's available in Staples. So yellow is like more common. You get yellow, lots more yellows. And because when you're doing the event storming process, it's like, you know, you're going to find a lot of events. So you're going to need a lot more events. So whatever color you choose, you're going to need a lot of. So, so I usually use yellow, but the trick is like, you know, have a legend, like when you're doing the event storming and say, okay, this color means this is a domain event. And you can even write, so how you name a domain event is like, you want to make sure it's named in the past tense because you only publish an event once it's actually happened. So it has to be in the past tense. And you want to name it in the context of the domain. It's not like, it's not a technology thing. Like it's not like a PDF file was generated. It's more like certified letter was shipped. A PDF was generated is very technical, like programmers understand that, but it doesn't have any domain significance. The significance here is like certified letter was shipped, or in this case, you know, aircraft type has changed. So we want to be careful. We want to try to use those rules. We want to use the words that the domain experts are using, and we want to kind of make it in the past tense. So, and we want to keep it in a natural, friendly language. So the reason for this is like, you know, when when you have aircraft type has changed, and that's the name of the event, and that's what you have in your code. And you have handlers that receive this event. And so when a business person or a domain expert, like, they can sit down with you, look at your code, and when they read aircraft type has changed, they do understand the context, the business context. So, but if the names are different, then that's where we get into the translation problem, right? Like we have to do the literal translation of what the domain expert said. That's like something else in this code. So we want to avoid that. So we want to use the language of the domain as much as possible. And that goes for all our events. So the first step, we identify what are all the significant events. Next is, so by doing that, you could get a vague idea of, okay, these events, are in the booking space, and that could be in the flight planning context. So you could get a general idea of like where these things belong. And and then the next step is like, so when an aircraft type has changed, what do you need to do? So we need to find a different proposal, right? So we're doing that. So when we do that, so we issue a command. So in this case, rebook. Now, based on that, if the command succeeds, you're going to have a new event saying like you were able to change the booking. And when the booking is changed, we notify the passenger about like, hey, your flight got changed from Boeing whatever to whatever. Here's your new booking. So now the passenger, can either choose to accept it or not. And so how long do we need to wait? Like, we as programmers, architects, leads, we don't know the answer. This is where we need to ask, like, our business domain experts and say, hey, once we notified the customer, like, how long do we need to wait to hear back? And what if they don't send us any any confirmation of either acceptance or rejection or acceptance? What do we do in that case? So we can't make those decisions, and that's where, like, doing this event storming process with the domain experts, we can ask these questions, and based on their answers, we can like model them as events or commands. So you can even like denote time as a message. So this is like a 30-second or a 2-minute overview of event storming. Obviously, the devil's in the details, right? So when I did this, it was funny. So I did a workshop in DDD Europe in February. So I did this example. It was the same example. So one group of people said like, hey, this is very simple, and like, look, we're done. And then, so I was like, okay, so what if your party had, 5 people, and because of the flight change, they can only accommodate 2. So how are you going to manage that? And let's say you got a ticket that was on the left side aisle of an aircraft, but that's no longer possible. Is that okay? So there are so many cases that we can't think of, but needs to be accounted for in the model, that, when we try to just start programming right away, we don't think about all these cases. But these rules have, they shape up like how the behavior of the code is going to be. So again, like modeling with post-its, even real time, or using Mural or Miro, might be a lot simpler than spending a lot of time writing code in my case, spending 1 month of time writing the wrong thing. And that's like waste of time. So our goal here is to collaborate and find all the business rules, the behavior of what we're trying to code. We want to know about the behavior, and how could we code that behavior in such a way that, it's easy to change later. So once we identify these commands and events, we can translate them to code. So this example is from in Service Bus. In-service bus is a framework for, is a messaging abstraction that works on top of RabbitMQ, Azure, and so on for .NET applications to help implement like event-driven architecture easier. So in this example, so I can take that event, aircraft type was changed. I can write like a handler. What do I need to do when I receive that event? All I got to do is like write whatever the logic is. And from there, I can send messages or receive messages. So what should happen in the handler when I'm trying to rebook the flight? I'm supposed to find a good route and publish. And for cases that involve like multiple messages, like for example, like we need to set a notification and we need to wait for if the person's like canceled or, you know, so we can then use the Saga pattern. So coding becomes easier, like once you know the events and the commands like that are involved in this business process. So spend more time in trying to understand what the business process is, and then it's a lot easier to translate that into code. Any questions, Jason?
Yeah, a couple more just rolled in. So I guess, so I'll just read the question. So does that mean DDD covers all test cases in software development covering the business logic?
I don't know if DDD covers it, but I think like if you apply DDD patterns and principles, then you are trying to make sure that the test cases that you write are handling like testing the behavior. So in this example, like I have the Saga, right? So the N-service bus framework, the framework offers a way that you can test the behavior of the Sagas. So where you can say that, you know, when this message, you know, when I have this event, and if my state object is, you know, in a certain state, you can assert like what the behavior is. Like you should have published a message or published an event, or you know, you might have requested a timeout message, or so you can assert that behavior. So you can definitely, you should be definitely focusing on finding out what the behavior is and see how you can test for that behavior in your code. I think if you do that, then that's good. Does that help?
I guess.
Okay.
No response. So I did see there are a couple of questions asking about bounded contexts and kind of their, so one was their relationship to microservices. Is it like one bounded context is one microservice, or is it multiple? And then can bounded contexts communicate synchronously?
So yeah, I will talk about the synchronous communication. I have a few slides for that. So bounded context is just like a loose space. So you can have one service, microservice, you can have 10 microservices, it doesn't matter. I think what matters is like, are those services that you have within that bounded context, are they sharing the same language? Are they accomplishing the same business behavior or rules that you're trying to, you know, accomplish? So I think that's more the key. So it's like a virtual boundary. So it doesn't map one-to-one. One bounded context doesn't mean like one microservice. You can have like 10 or 20 microservices as part of one bounded context. So it's just a way of saying that, you know, these things that's part of the bounded context share the same language. So they have the language boundary and they serve a business purpose. So that's how I try to look at bounded context. Does that help?
Yeah. Okay, and where was it? Okay, what's the difference between domain-driven and event-driven?
So domain-driven design is just a set of guiding principles, and event-driven architecture is a style of architecture. So I look at DDD as a set of guiding principles, and EDA, event-driven architecture, is like a style of architecture. It's so it's like you've got N-tier architecture where you've got like a UI layer, business logic layer, data layer, and so on. So that's just a style of doing things. So in event-driven style, instead of having these, so you're primarily using messages to communicate between other services. I will touch upon like the synchronous behavior, but what I wanted to emphasize is like naming things are really hard. It is incredibly hard. When I've done these event storming exercises, the one common thread that I find is coming up with good event names are really, really, really hard. And so to give an example, like we are so, I mean, CRUD is like so ingrained in us. So when we start naming our events, like even though like we apply the rules, right? The good naming principles, which is for an event, it should be in the past tense. And so we say customer was created. So it's in the past tense, it looks like an event, but are we really creating customers? Like, is that our thing? Like, it would be so cool if like every business can create customers, right? So it might be that comes from our practice of like create, update, delete. So customer was deleted, customer was updated. We don't do any of those things. A customer might get onboarded, or like it might not even be a customer that gets onboarded. Like for like, you know, the purposes, it could be a lead before they become a customer, right? It's just first a lead, and then they have to buy products or services, licenses from us, and then they become our customers. So, or they could be like an onboarding process. So we want to try to use as much as possible, the domain concepts and bring that into our code, and always like double check the names. This is where it really helps to have some sort of like have another person, domain expert, kind of like, you know, review these names with you, just to make sure that that these names that you're using everywhere in the code actually mean what mean the right thing in the domain, in the context of the domain. Also, like, events and messages are supposed to help you be loosely coupled. You got to be careful here, because if you put a lot of stuff in these messages, then you are getting coupled, not, you know, now to the schema. So when you publish an event, you need to make sure that whatever you put in the event, in the schema, in the body of the message, you know, is what is absolutely required. If you start throwing in a lot of unnecessary things, now the receiving party is going to get all of those things. And then they might start to make decisions based on that, based on those attributes in that event. So you want to make sure that you only expose like what is like relevant. And you want, so I think of it as like, you know, like, what do you want to leak out of this bounded context? Leak is like typically like a bad association, right? You don't want to leak stuff. So so that's why you want to be careful. You want to only put like whatever is the absolute necessary things in your events. So naming things are hard. You want to always like try to talk to your domain experts, or have a person that's like very obsessive about language, you know, code review the names as you come up with, and so the goal is, we want to call our events based on the actual domain things and not like CRUD based. Now, if we look at the original requirement, you said that the passenger gets notified with a new booking proposal. But when I modeled it at first, like I had called it rebook flight, and book flight was changed and so on. We're not rebooking flight. We're only like, you know, having a new proposal. So it's not rebook flight, it should be proposed rebooking. So the point of this is like, you are going to find out things about your model. It may not be right. And based on conversations with the domain experts, you want to take that knowledge of what you learned and then apply those changes, refactor your events and schema to match your understanding. Because the goal again here is to take whatever the business behavior we want, and we want to make sure that our software models reflect that reality. And it's not going to reflect that reality if we don't refactor those changes in. So when we come to an understanding that, oh, okay, our original model is actually incorrect, we were trying to do a proposal and we called some things different, go ahead, it's okay, and go and refactor to what your new understanding is. So now your model is like more accurate with the business behavior. So that's what you want to strive for. Have a healthy obsession with language. So make the implicit explicit. So here I used to have this habit of writing my handlers where like I'll put the event name and tag a handler. But that doesn't really tell me what that class is actually doing, right? It's like aircraft type was changed handler. Yeah, it handles that event. What's the intent of the class? So, come up with meaningful names. This is like, so this class was actually doing new proposals. So make that, explicit. Say what this class is actually doing. Handler is just like an implementation detail. You don't need that. Again, like here, the Saga is a booking change policy. That doesn't say what it's trying to do. Again, make the implicit explicit. So here, this thing was actually checking for grace period. Like if the passenger hasn't responded in whatever 24 hours, like what we need to do. So so that's what it was doing. So make that more visible. So you can take some of these domain-driven design principles, and these are some ways where you can apply that to your code. And messages themselves are immutable. And if you use something like refactor, when you try to declare like an event, like you get the setters and the getters and the setters, but you don't need a setter, and you can use a construction time. You can set the properties of construction time. That's much better behavior anyway. So, and there may be some concepts that are like immutable in the domain. So for example, if you're working in the accounting domain, like once you make some changes, you can't go and update it. You might need to make corrections, or like, have an addition on top, like as a correction. So certain things might be immutable in the domain. So see if you can make those immutable concepts in your code. Like if the language that you're working with, gives you an option to make something as immutable, try to do that. So if you can't do it in the domain, your code shouldn't allow you to do it either. But again, the counter heuristic is like, don't fight your tool or don't fight your framework. You're trying to make something immutable, and let's say you have to fight a lot with the tool or the language, then it's not worth it. So if it's possible, try to bring in these ideas from your domain into your code. So this is the part that I wanted to talk to you about. Like this, someone had a question about like, do bounded context, like, do synchronous communication. Now let's say we tweak our requirement to say that, like, hey, all these things like notification and rebooking and finding new proposal, it should only happen to people who are flying business class or platinum class, right? So now all of a sudden we are in a situation where you've got the booking context and it receives this aircraft type as changed event, but now it has to make a determination of whether this passenger is gold or platinum pro, because only then this whole thing makes sense. Otherwise it needs to just ignore. So now it needs to go out and get this information from the loyalty context. And then once it gets the loyalty context, it does whatever it needs to do, and it publishes another event. So, but in this model, you could say that these two models are temporally coupled. So when you do this sort of thing, right, when you have like in this case, think about it as a bounded context. You've got one module, one microservice inside the booking context, trying to go talk to another bounded context synchronously. You have temporal coupling. Temporal means like, dealing with time. Coupling is just a dependency. So in this model, what happens is, let's say the loyalty booking context is down, or some of the services are down. Now, you can't process this rebooking because the loyalty thing is down. So now this is, in my experience, this is like the one factor that keeps you from scaling. So when people say, hey, I have a bottleneck and I can't scale, it's usually that, two services are synchronously have some sort of synchronous communication and they can't scale up. In the example that I gave you, or in the domain that I was working on, we had this business case, or we had like very strict SLAs of when we had to deliver things. And for this one customer, we were meeting SLAs, but we were extremely like close. And so we were trying to see like, what was the process? Why is it taking so long? And then we narrowed it down to as part of the business process, there was a call to billing service, which was trying to compute the price of that letter based on whatever the user had chosen. So for each line in the CSV, there was a call to the billing. So it was so depending on the size of the batch, it could take a long time. So once we identified that, we went and asked the billing team, like, hey, so is this necessary? Because it was making that computation and then it was updating some table, the transaction table, which had like 200 fields, and it was adding some value, but we weren't sure if it was actually being used. So when we asked them, they said that no, it's no longer used. We moved away from that computation, so it's no longer used. So we got lucky. All we had to do was just like remove that one change, and then we were fine. But it can get you into tricky situations, and this is sort of like my first learning. And so how do we address this? So again, this is where queues and messages come in really handy. So we want to make autonomous decisions. We want to be able to go to a model where you can have like these two services. It doesn't matter whether they're up or they're down. We should be able to work in a manner. So let's say we get this we have this loyalty, right? So let's say loyalty is now publishing events. Every time a customer is promoted to gold or platinum, it just publishes events. Now booking module gets those events, and it's interested in knowing whether the customer is gold or preferred, because it needs to know what to do. So what it's doing is, in its own database, it's just putting that information. So now when flight planning publishes aircraft type has changed, booking does not need to go back to loyalty, because it holds this information about the passenger in its own database. So when you're trying to propose the rebooking, it can, sorry, the dog's going crazy again. So it can check its own database and make autonomous decisions. So in this model, what happens is, it doesn't matter if loyalty is up or down, because booking can still function independently. So this is where, like, if you have this is why I prefer publishing events between bounded contexts, exactly for this reason of like, having these two bounded contexts be autonomous. So they cannot be autonomous if you have synchronous requests going on trying to get data. So to decouple that, you can introduce messages and a queue, and you can process it this way. Now, part of like say loyalty, right? You might have like a third-party service, and they might need to do synchronous communication. Of course, we're going to have to interact with a lot of third-party services, but you're going to have some synchronous communication. But they usually happen within a bounded context. So where you know, you're not holding, like if some that third party, if it's down, it's going to impact loyalty, but not booking. So does this explain the question about the synchronous communication on bounded context? I'm going to assume yes. So
there was a question that came out of that.
sure.
I'm not. It might have been the same person.
Okay.
Does that not mean that status is shared duplicated across these two bounded contexts?
Yes. So yes, it is right, but it's okay because that's why, like when we're publishing events between bounded contexts, we need to be careful of what, like how much data we're exposing. So, and this bounded context is the loyalty is still going to be the what do you call the statement of truth database for customers, right? No one's going to go into the booking and ask for, is this customer you know, preferred or not. So loyalty context is still going to be the system of record for that information. But what this allows you to do is to make decisions autonomously. So by I mean, even if you did synchronous communication, that doesn't mean like you're going to be always right. Just as soon as you went and got that data could have changed. So that doesn't mean your data, you know, you're still like, you know, using the right information. This style or this design, what it brings up to the surface is that this information is stale. So what you need to have conversations is like, hey, how long, you know, let's say if the customer, you know, we've given discount based on the fact that he's a business customer, or, you know, we've done this decision. Let's say that, like, you know, a few seconds later, that's no longer the case. You know, what are we going to do about it? You know, what is our tolerance policy? Are we going to go and make an adjustment? And those are things that this design, you know, bubbles up to the surface. And we're going to have these sort of conversations with our business and figure out what we need to do. So in my experience, like when I bought something from Amazon, for whatever reason, like my shipping cost was something. So I paid, like, you know, at the time, I paid like whatever, $15.55. And then I had like a refund of like 25 cents or 40 cents based on some calculation that happened after. So basically some rule had changed. So they had made a compensation, and then that amount was refunded to me. So based on this staleness, and if something needs to happen, like we can apply a business rule and then take that as a separate compensating action to do whatever we need to do. But what this allows you to do is, like, you know, have these two services autonomous. If they're autonomous, then you can scale them independently. You don't have to bring them up. I mean, you don't have to bring them, they don't always have to be up. You can still process messages in both ends. So yes, there is a certain amount of duplicate data that you're storing, but that's just to help you make that decision autonomously. You are bringing this is eventual consistency. You're saying that, you know, eventually this information is going to get updated. So what level of eventual consistency are we okay with? And in some important cases, we might need to take a compensating action. But those are business decisions that we need to ask the domain experts. Does that help?
So there was an additional question asking about so status needs to have some timestamp inside booking to address the staleness.
Sure. Yeah, you can. Yeah, definitely. I find timestamps extremely useful. And yes, so depending on the timestamp can be useful in so many ways. So, so yes, so what goes on into the event is definitely a whole topic in itself. So, but what I wanted to say is like, if you design it like this, the deployment models become like simpler and can yield to things like side-by-side deployment or experimentation A/B type of deployment. So let's say you had a version 1, and then now you're trying to deploy version 2. You don't actually have to bring V1 down, because they're sharing, if you're using RabbitMQ or more modern broker, then you can, sorry, just give me a second. You can actually use, so RabbitMQ like has a competing consumer pattern. So so both these modules V1.0 and 1.1 is actually looking at the same queue. So what happens is like some messages would go to the original V1, and then some messages would go into the new version. So when that happens, if everything goes well, then at some point you can like stop version 1, and then all of the messages are going to flow directly to your new version. Everything is good. And so you can apply this model not just for like V1 and V1.1 type of thing, but let's say you business is trying to do some A/B testing, where certain people in certain regions are going to get certain promotions. So you could introduce like the different experiments, you know, where some messages are going to go through experiment 1, some messages are going to go to experiment 2, and then business can decide like, you know, how is it working? Is it really working for us? Do we want to keep this or not? So then they can say, okay, we find that this is the good promotion. We're gonna keep this model, and so they can stop the other one. So that's also use of this type of designing. Now we all know deployments not always like goes well. So you deploy your V1.1, and then you start finding out every message that goes into this thing is a failing. So so what do we do? Now, when it fails, so we can have some kind of, so failure can be like transient failure, or like you know, something that fails every single time. So if it's something like a transient failure, where your database isn't like available for a millisecond, where you get a deadlock exception, then when you retry those will get resolved. But let's say you have a null reference exception because this is new code, and we didn't like, you know, think about something, and it's throwing a null reference exception. Now that code, no matter how many times you retry, it's always going to end up in a null reference exception. So we have like a config, like, you know, a certain number of retries, and after that we forward that message to what is called as a error queue, or a so you consider that message as poison message, because you don't want to effectively DOS your own self, right? We know that this doesn't work. We want to take that, we say this is a poison message, we shove it to a different queue. And then what happens is, because this is like a deployment, and so we can take that message, and we can stop, of course, our problem deployment, and then we can take that message and flow it back to the original version to process it correctly, so we're not having a lot of downtime. So this style of, you know, of deployment is possible, you know, when they're small and when they're autonomous. And if your change, for this to work, your change needs to be done in a backwards compatible way. So what I mean is, like when you're making changes to say database schema, don't like, change the meaning of existing fields, add things instead of like removing stuff from the event schema. So be conscious always of like, how is this going to work? If I change this event, how is this going to affect my downstream subscribers? How are they going to affect and react to this change? So we want to be mindful of like, the change, and want to write it in such a way that it's backwards compatible. And if we do that, then this style of deployment is feasible. And so I want you to remember three things, if not, on this discussion today. First thing is like, code is a lot. I think code is a lot easier, but figuring out like what to write, that to me is the much harder part. And that's where talking to domain experts help, and having some sort of like a visualization using event storming or domain storytelling or whatever principles that we're trying to do. That's great. But collaboration and communication to me is the hardest thing. And there are several books on that. So I've used several books to try to help me understand like how can I be an effective communicator? Because oftentimes it's all about like trying to say something in a way that makes sense. Getting our points across. How can we listen to each other? I think that is the hardest part. So and then understand that our models are not perfect. And according to George Box, the statistician, I mean, he said like all models are wrong, but some are useful. And understanding that like our first try, it's not going to be right, but that's completely okay. Our value of DDD comes in when you start listening to domain experts and trying to translate that knowledge constantly, and taking that knowledge and refactoring. So in the example I showed you, I originally called it like, booking flight instead of booking a proposal. So like once I found that mistake, I went and refactored my models. My first model was actually wrong. Doing it in a code review with a trusted friend like helped me. And in this case, like, it could be like a domain expert saying that, hey, this is not, we're not booking flights here, we're just trying to do proposals. And then so once you understand that and taking that knowledge and then religiously refactoring your existing models to match that domain knowledge, that business behavior, that's the key. If our code is in line with the actual business behavior, then like, extending stuff becomes a lot easier. But we can see like which part of our code is this behavior in, and if we want to extend this behavior, how could we do that? By using patterns like events to communicate between bounded contexts. So what happens is like you can start building things completely on the outside. So for a new feature that comes in, you don't have to touch your existing code. So the example, like in the domain that I was working with, the regulation stuff came like much later. So we were doing shipping letters and stuff. And then suddenly we had regulation requirements from certain states. They said like, hey, every time you send a notice of default to a homeowner, you have to register that loan information for that homeowner to us, the government, the state government. So they had provided APIs or portals where we had to submit that. So all of a sudden, that's a new requirement, and we have to write that, right? But we can do it in a way that we don't have to go and touch the legacy code, because we made the legacy code publish events saying that certified letter was shipped. The whole regulatory stuff was completely written based on subscription to that event where we were able to model all the rules for every individual state, separately, and we were able to align along the business lines. So so this is where I think like events and using an event-driven style of communication is like very, very powerful. And yes, there is going to be some duplication. They may be, but it gets you this autonomy, which is great, and it also bubbles up like whatever your expectations are, and see how you can address those business rules. So just remember these three things: communication and your models, constant refactor, and then use messages for asynchrony and communication. So I wanted to say one thing. Okay, so Unisys, the group that I'm working for application services. Part of what I do is I work with our clients and help them understand like their applications and like see how we can take this legacy application and try to modernize that. So these days it's the cloud, and so my group is actually looking for someone. We're hiring, so if you have cloud expertise, have done migrations, please ping me. I would love to hear from you. By the way, thank you so much for having me. It was such a pleasure. And of course, I'm here to answer questions for a few more minutes before I go tend to the dog. Thanks.
Cool. Well, yeah, thanks for the talk. There is one question that I feel like could be a talk unto itself.
Okay.
But it's asking about the relationship between UI and bounded contexts.
Yeah. Okay. So yeah, that is a talk in itself. So I think the goal is like if you like think about like a slice of functionality from top to bottom. So there's like a UI piece that's going to talk to some what do you call some it might need to send a message. So if you try to align along the vertical slice, then you're better off. But then how do you do it in the UI? There's like several styles. Like I think particular software has like a labs project where they show you how to do that UI style decomposition. Like in the UI, like how at a UI level you can like still like have this service can put a component as part of the UI that knows how to get just the part. Like for example, like that page from Amazon, right? That's like showing all of the stuff like price and product availability and stuff. You can think about like that page as being composed of different services, and different services are plugging in the data for what they know. So that whole thing is doable. This like server-side composition and client-side composition of how you can do that. So yeah, that's a big topic by itself. But if for .NET folks, I think Labs has a project called NetCore Demo, where they show how to do that UI level decomposition, where each microservice is just providing its data, and then but from the UI perspective, you're still like tying and stitching the whole thing together.